Hey guys, so today we'll be discussing an important question. And the reason I selected this problem is because this question actually looks a very straightforward thing. There is nothing fancy about it. Because what you have been told here is that you're given a binary tree and you have to tell me that whether it follows the property of heap. So how do we even approach these kind of problems? So before that, we need to understand what are the properties of heap. So the property of heap is as follow. It should be complete and it should follow the property of heap, which is not very well worded. But what it means is key, the value of each node is greater than equal to its children. And I will even explain what does even complete mean over here. Let's start with a given example. Let's say that we are given a node A, right? And we draw its children. Let's say that we start drawing its children. The children will be B and its children will be C. Now, this is a complete binary tree because A has both of the children. Remember that, right? Now, you might say that let's complex it further, not that much, but let's add few more nodes. So now B has two nodes, right? And again, this is a complete binary tree. So let's start deleting E element. And can we say that this is still a complete binary tree? According to the question, yes, because it says that all the nodes are as left as possible. So even though there is only one children of B, all its nodes are to the left as possible because they go here. In when you are playing with heap, and why this is I will tell you. When you're playing with heap, you do not put a constraint. I mean, you have solved a lot of questions. Does the question put you a constraint that hey, you can only put even number of elements? No, you can have odd number of elements. But when we are having odd number of elements, what does the question says is ki, what does the heap says? All the roots or the nodes should be as left as possible. So that's it. Since we have now justified the definition of the complete binary tree, we will now go ahead. And before that, I'll just give you one trivia. Do you think this is a complete binary tree for the given question? Does this property satisfy? No. Because this node is actually on the right. This node is actually on the right and it dissatisfies the property of the binary tree heap. So that's why this is an incorrect one. Now let's try to understand one more given constraint, right? So the question also says that it also talks about the number. Let's start putting number over here, right? And let's say that the root number was something 100 and children was like 20 and this was 30 and this is 1 and this is 2. Do you think this is a this is a complete binary tree? Yep. But do you think this does it now satisfy the property of the maxi? Yes. Why? Because all the you see 100 over here. 100 is greater than its children, right? It says yes, I'm greater than you, I'm greater than you. Same thing is followed on the left hand side. 20 also says that it's check its children. The children are 1 and 2, and it says that hey, I'm greater. That's all. That's all. Since we now have a pretty good understanding, let's see how we can actually solve this given problem. So one thing to remember over here is that guys, you might be first thinking that how do we actually start traversing this given, right? This is a tree. How do we start the traversal? So we have different kind of traversal over here. We have post order, right? We have pre-order and we have in order. I will not write down the entire names, but these are the primary ones whenever you encounter a tree. But do not restrict your mind. Do not restrict your mind. There can be other kind of traversal as well. There can be a DFS based traversal. There can be BFS based traversal. But DFS is nothing but this is only because at the end what we are doing, we are just recursing. Since we have now justified how what are the different type of possibilities, I'm going to first start with the approach of see, whenever we get a tree question now, even in interview, the first chain of thought will be that we are going to use something like pre-order, post-order, or pre-order, right? But let's try to understand what are the takes of this given thing and how we can eventually solve this. Let's start with the root A. Root A will have its children, let's say that, right? And let's say that we want to take the property of the max heap. So what is the property of max heap? The first thing is that A should be greater than equal to B and A should be greater than equal to C, right? This is the basic property which has to be satisfied. Yep, let's say that it's satisfied now. But how do we satisfy the next given thing? Let's say that B also has children. Let's say that the children are F and G, right? So there are two children. But now we have only claimed that A satisfy the property. We have not claimed that B is also satisfying, and we have not claimed yet the C has also satisfied, because we are at the first at we are at the root. Because any traversal which we begin, we let's say that we started from the root, we just check the left and right. So that's why this problem becomes very intuitive to solve. So how do we actually then solve it? Because how do we then justify ki देखो, if a has to check whether it's greater than its children, it will just check its immediate value. The left should exist and the right should exist, as simple as that. Yep. But now A will say that, hey, I have done my part. I have proven myself to be worthy of part of this tree. Now you, B and C, are responsible to tell me that are you worthy of being part of this tree? And how this will work out eventually? This will work out because the first will return true. And then we can just do an iterative, or we can do a recursive call. We can do a recursive call on the B and a recursive call on C. Right? And B and C are nothing. B and C are nothing but root left. They are nothing but root left. And this is also root right. है ना? So eventually we say that we first check the criteria. If the given node satisfy the property of the max heap, and if yes, we have to put an AND operator. We have to eventually put an AND operator for these two, because it is possible that these B and C can dissatisfy the property. If either of them dissatisfy the property of max heap, they will return false, and we have to carry forward this false from anywhere to the final answer, right? That is the important criteria over here. And in what given scenario this tree will not be a max heap? When A is less than B, or or A is less than C. In these given scenario, we can clearly say that, hey, this given tree is not following the property of a binary heap, right? So let's try to understand what are the next given thing. So right now we know that this can be happily taken care of. This can be happily taken care of. And the only thing which we need to worry about is here root and the null values. So root we can handle, but null values will be pretty difficult, because null values, right? When we reach the leaf node, what will eventually happen is that when we reach a leaf node, the left and the right will both be null. So in this given scenario, do you think this follows a property of a max heap? Like, yes, it does, because we are just claiming that, hey, since no child exists, it does. You are the only, and eventually we're gonna have to say that this one is true, and eventually for here also we have to say that this one is true. So because we can't say na, देखो, if there was one over here and there was two here, we don't have any children over here, like that is satisfied, and there are no elements. The children's are just, there are no children, so eventually this has to be justified, like it's a single node, so why not, right? So you need to handle this case separately. Now let's try to understand one more given thing over here. So up till now we have just said that we are just checking the second property, right? We are just checking the second property, and checking the second property is not a big deal. You can do it yourself as well. I have full faith in you, because it's a pretty forward if else while condition check. You have to check for the leaf, you have to check for the base whenever you encounter a root, and at the end, if the left and right exist, you have to do a recursive call, and you have to ensure that both you have to take the AND of both left recursion and right recursion, and then you have to return. But let's try to understand what will happen if the tree is incomplete. Right now we have only focused on the tree being complete, but we have not taken care of tree being incomplete. So how we can eventually handle that case? Let's say that there were further given elements like this, like D. Okay, now obviously this tree, the element, the root is there obviously, but the node D is not as left as possible. It is on the right hand side, so this becomes troublesome for us. So how do you think we should handle this problem over here now? How do you think we should handle this? So this is where the trick lies. This is where the trick lies, because I'm going to straightforward give you the clue. Eventually, we are going to use some property, eventually, which I think so you might have done in the school days, or sorry, in your, not in the school days, in your earlier college days. So this is nothing but 2 into I plus 1 and 2 into I plus 2. So these are the two given formula which you have to use. So remember, I think so you might have seen that we had another kind of traversal when we were be given that, hey, if A is the, we will start with A and then we will just start traversing the array. And during this traversal, we are going to assume that I is equal to 0 for B, right? I is equal to 0 for B. And then we're going to solve the values over here. So eventually we would have gotten here 1, and eventually over here we would have gotten 2 for the C. So these are the given value which we index value. These are the index value, remember that. Okay, this would be index values. So in college days, you might have solved this kind of questions. Now the next thing which you need to remember that, what about this? What about this? So this comes very handy, right? I'll tell you why. Because now let's say that we know the total count of the node. Okay? You know the total count will be what? Total count will be 4, 1, 2, 3, 4, as simple as that. But remember this. Okay, this also we mark it as 0. This is the, basically we are assigning some indexes or unique values to some every given node. So how do we calculate the next values? The next value will be calculated based on the parent value. So this will be nothing but 2 into 1 plus 1. So this will get a value of 3. So this will get a value of 3. And I'm sorry, this will be 2 into 1 plus 2 because it is on the right hand side. This is on the right hand side. And that's why we're going to use this formula. So this will get a value of what? 2 into 1 plus 2. That will be equal to 4. Right? And similarly over here, C has no children over here. C has no children. So what would have happened? You see there is a discrepancy in this because now what has happened is we have skipped this part and we have placed the D over here. We have placed the D over here, right? And we know, when we know this one given thing, that if we had if we had done the indexing like this, we would have gotten only 4 given nodes. But if you take the 0 indexing, right, we are taking the 0 indexing and then counting, right? And if we take this D now, this D tells us that there are only 5 there are 5 given nodes which are present, right? So this is a discrepancy which is present over this tree, and this becomes true for all given cases where the tree is not left side aligned. The tree is not left side aligned. So let's try to understand what would have happened. What would have happened if the D was on the left hand side? The D on the left hand side would look like something like this. And to calculate its value, we would use the formula 2 into I plus 1. And we know that I is equal to 1. So this would get a value of 3, right? This would have gotten a value of 3. And 3 very well fall within the range. 3 is less than 4. That's why we're going to say that, hey, this satisfies the property of complete binary tree. So that's why I said that this question is actually pretty tricky. It's a pretty tricky question. So this was a one given approach which was there. I wanted to discuss one more given approach for this given problem. Let's discuss that as well. Now let's try to understand what other traversals are there. There is another traversal called BFS, best friends forever. No, but not best friends. But anyways, I don't want to go there. So let's say that we want to study the BFS one, how we can eventually use that. So what happens in the BFS? We take the root node A and then we put it in a queue. Then we put it in a queue. Let's say that we put A in the queue, right? And after that, we start popping up the elements from the queue and then we start iterating the given tree. So let's say that this is a B and this is C, right? And let's say that we keep on adding elements, right? This will be D and this will be E. So how do we ensure that this given this tree actually follows the property of a this one? How does it satisfy the completeness and the max heap? So one thing over here is that we can quickly check now. Whenever you're iterating, whenever you're popping any element from the queue, let's say that this was your queue, and whenever you were popping some elements from the queue, you would be rest assured now it would have a right and it would have a right value and a left value. Right value exist करेगा, left value भी exist करेगा. And what you have to eventually do is that you have to check if A is greater than equal to B and if A is greater than equal to C. Eventually you have to check this thing, right? And let's say that this thing is satisfied, then we're gonna keep on adding the elements in a given queue. At any point, at any given point, if this rule breaks, then what we have to eventually do is that we have to return false. We have to return false. But now you might ask me, hey, how do we eventually solve the problem of the completeness? So let's try to understand what will happen. right? Let's try to understand what will eventually happen over here. So let's say that कि if we detected a null, देखो जैसे ही हमने पहले null detect किया, हम we are going level by level now. We would have completed A level, and then we would have completed B and C level, and then we would have encountered a first null. We would have encountered a first null. So why can't we go ahead and maintain a flag? Why can't we go ahead and maintain a flag which says that whenever I found a null, I'm going to set this flag as true, right? I'm going to set this flag as true. Now, any given element, I don't care, any given element I find at this point, after this point, I'm just going to say that you should have not existed, and my tree becomes invalid. So this is why this BFS approach is pretty simple over here, right? So I hope you understand, right, how it makes sense. Now let's say that in the given fact key this thing was not present. Let's say that key there was, let me quickly erase it, right? Now let's say that key there was some value over here D, right? And here यहाँ पे null होगा. Now, what would have happened is that a null, as soon as we detect a null, we say that we maintain a flag and we set that flag as true. Now, if any given point, if C has any element, we would have popped C and we would have start visiting start visiting his student. Let's say that C के कुछ student है, D तो already बोल दिया, F. So now if we have traversed the C के children at this point, we would have quickly caught it. We would have तुरंत पकड़ लिया रहेगा कि देखो यार f exists कर रहा है, and we have already someone has already set this flag as true. So that's how we are going to solve this problem using the BFS based approach. So I hope it makes sense to you guys. Let me actually try to code this thing, dude. I'm not even sure, and I mean you can stay here if you want, but eventually there is nothing more to explain. Yeah, people, I don't know why they want people to stay till the end of the video. But I feel like this is all I had to explain. So I'm just practicing my coding at this point. If I can code this given thing, because a lot of the YouTubers actually they claim that yeah we can solve this given problem. So I have declared a tree. See, I'm not a good coder. I'll tell you that. I'm a good logician type of thing. I can pretty much explain good problems, but sometimes I have my own difficulties. So you know what, people do mistakes over here. They eventually say कि, when they start popping out, they pop out the, instead of a node they forget that they were using node. So ये सब छोटी छोटी mistakes का I keep blundering. So yeah, that's there. So let's call it node only यार. See, node को pop करेंगे, क्यों से इसको front लिखते हैं पहली बात तो, and इसको pop कर देंगे, ठीक है? And since we are using a BFS based approach, what we can do is that मैंने एक flag भी बोला था ना यार, उस flag को भी नाम देते हैं false, और इसका नाम देते हैं null checker, कुछ तो ऐसा, ताकि अच्छा नाम लगे, null checker, ठीक है? इसको बोल देंगे हम लोग false है, क्योंकि अभी तक we have not detected any null node, right? And then for the given node, see, one thing, remember that guys, do not store the int value, because कोई लोग क्या करते हैं ना कि they end up storing the int values and they start traversing the left and right. यार तुम अगर if you end up storing the int value, how will you traverse? How can you reference to the left value? How can you reference to the right value? You cannot, right? So we will have conditions over here. Okay? If the left value exists, then we will have conditions, and if the right value exists, then we will have some given conditions over here. So let's try to put it over here like this. Okay? So this is how we should go. यहाँ पे देखना, अगर if the node left does not exist, what we can quickly say is that कि null checker को true false set कर दो ना यार, पहली बात तो, ठीक है? null checker को true set कर दो, यहाँ पे भी null checker को true set कर दो anytime. And after this, in this given loop, we have to smartly check if the null checker is इक्वल टू, अरे ट्रू तो डायरेक्ट ही हो जाएगा ना, इक्वल टू क्यों कर रहा हूँ मैं? और एक और चीज कर सकते हैं कि नोड लेफ्ट को हम लोग, देखो ये चीज साथ में चेक करने की जरूरत नहीं है. देयर इज नो रिक्वायरमेंट टू चेक द डी डी इज लेस देन इक्वल टू बी, ठीक है? मतलब ये अलग से चेक कर दो, ठीक है? मैंने भी पहले एक्सप्लेन किया, आई डोंट थिंक सो आई हैव टू रिपीट इट आउट टू यू गाइस. सो आई एम जस्ट डूइंग दैट ओनली। देखना मैं बस फॉल्स का कंडीशन रिटर्न करने का सोच रहा हूँ। यहाँ से मैं रिटर्न फॉल्स कर दूंगा। ठीक है। ये फॉल्स कैसे होगा कि इंट इस जो लेफ्ट साइड की वैल्यू है ना, इफ द लेफ्ट साइड वैल्यू, लेट्स go this side door. I cannot see my screen. It's why they have this chat window. So at this point, what we can eventually say is that कि if the node, हाँ ये क्या करेंगे, node की value greater than हो गई, node dot, अरे यार क्या गंदे लोग हैं, node dot node mean value, then we are going to return a false, right? Otherwise, we can just keep on continuing. We don't care. Same thing we can do over here as well. If the null checker is true, okay, if the null checker is true, and if the no dot right is key value is greater than equal to the node value, that time we can clearly say that key this tree is not following the property of a maxi. Okay, let me quickly check if I have written it correctly or not. Yeah, I'm not. देखो, we have a queue, then we push this given node in this queue, right? We push the tree. Now we have initialized the null checker, and then we have a empty thing. After that, we have taken the front value and we pop the front value, and we will keep popping the front, like we will keep iterating until the queue runs out, right? And some people actually say that कि you can use a for loop, but actually यहाँ पे for loop की कोई जरूरत नहीं है. Some people actually do that, right? Because in traditional ways they would have used a for loop to see the queue size, and then they run this for loop. But now there is no criteria now. Understand that there is no criteria here because we are not interested in level by level traversal at this point. We just want to see ki at any point if these given property break. So if any point this property breaks, what you can eventually check is that ki these conditions you can check, right? These conditions you can check. And right now if we have verified everything, let's say कि यहाँ तक कहानी अच्छी चल रही है, तो यहाँ पे रिटर्न ट्रू कर दो ना यार, कि अगर कहीं से रिटर्न फॉल्स नहीं आ रहा तो यू कैन रिटर्न ट्रू. I am not sure if this code is gonna run, so let's see, let's hope. So we have a compilation error and it says that ki it has no value. Oh, it's some data value. So let's the funny thing over here is that oh Geeko you have that. क्या smart लोग है भाई. So it has a replace all functionality. Yeah? Regex searcher, case sensitive, wide word searcher. Guys, it's up to you guys. I mean, if you want to stay, you can stay till this point. I usually do not encourage my audience. It's just for my self practice. I'm just gonna say that. Value को data से replace कर दो. Bye. Just replace all. Oh, this is the first time I'm using these things. All. अरे यार इससे ज़्यादा मैं type करता हूँ. Thank God I have not used it at a very large scale. So let's see. और भी कुछ compilation error था क्या? I don't think so. There will be compilation errors. अगर पास हो तो ठीक है गाइस, नहीं तो कॉन्सेप्ट समझ के रख लो. So I see that it has failed and we need to understand why it failed at this given point. So let's see कि अब क्या गलत किया हमने इधर. So right now we know that कि we have satisfied the property of a null checker, right? यहाँ पे null checker अगर given false आ गया, okay dude, I don't want to bluff you guys कि कोड गलत है, ये गलत है. I just want to see कि if we can fix it over here or not. And let's see क्या गलत था भाई इधर. ये यार मेरे टेस्ट केसेस कहाँ गए? फिफ्थ वाले टेस्ट केस पे गलत दे रहा है ना. ओके, योर आउटपुट फॉल्स, एक्सपेक्टेड आउटपुट फॉल्स. अच्छा हाँ, सबमिट करने पे देखते हैं क्या आता है. मीनवाइल आई विल सी व्हाट डू आई डिड रॉन्ग. सो इट सेज कि कॉपी टू क्लिपबोर्ड, ये कॉपी करना मुझे. आई वांट टू सी हाउ दिस ट्री इज रिप्रेजेंटेड ओवर हियर. सो हाँ, ये चीज तो फेल होनी चाहिए यार. ये चीज कैसे फेल हुई हम ये देखते हैं. तो इनिशियली क्या क्या रहेगा हमने, हम यहाँ पे सोचते हैं क्या क्या रहेगा. हम सोचते हैं भाई लाइव डिबगिंग हो रहा है इधर, तो we would have pushed the root over here, right? We would have pushed the tree node. We would have pushed 6 and after that, अरे भाई क्या गंदा इंसान है भाई, क्या गंदा इंसान है. उसके बाद वैल्यू कौन डालेगा भाई. हाय 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 हाय. बोलता ना कभी कभार लाइव कोडिंग में इतनी गलती कर देगा ना. लाइव कोडिंग क्या करो. सो देखना यार कि यहाँ पे एक्चुअली ना ये भी कंडीशन नहीं रखना चाहिए मुझे। मुझे कंडीशन क्या रखना चाहिए, इफ द लेफ्ट वैल्यू एग्जिस्ट देन वी कैन पुश अप द लेफ्ट वैल्यू, एंड इफ द राइट वैल्यू एग्जिस्ट देन वी कैन पुश अप द राइट वैल्यू, एंड लेट्स ट्राई टू सी इफ we can copy this test case, dude. We can. I completely forgot that कि इसको push भी करना है यार। गलती हो जाती है, मतलब I'm not saying कि I'm not perfect man, just saying कि I'm just a man। Let's see if it runs or not, dude. Otherwise, I'll see कि क्या कर सकते हैं इसके बाद। Oh my god, crazy हो गया भाई, crazy हो गया, चल गया। तो हाँ, वैसे थोड़ी बहुत गलती होती रहती है मेरे साथ, but please take care. You do not do these kind of mistakes during the interview. I have blundered a lot of interviews because I could not find the given mistake in my solution. So yeah, I mean, it's life is there. It goes up and down. But I hope you enjoyed the session. See you. Hasta la vista.